Hello everyone, welcome to episode 4. So in this episode we're picking up where we left off in the last one. In the last episode we actually got ourselves working with the conversation manager, and our dialogue system is now reading files from our dialogue resources section, and it's taking all those lines and rendering them to the screen, and that's fantastic. But we're going to focus on a couple more features that will allow us to take this a step further, and specifically that goes into finalizing our dialogue parsing system. I know what everyone's thinking, and that is that we'd like to go ahead and get into characters and get into backgrounds and everything else that makes the visual novel what it is. And we will get there very soon. There's just one more thing we got to get out of the way, and that's finishing up our parsing system to include the advanced capabilities for character name casting, position casting, different dialogue segments on the same line, as well as sending our commands and our arguments to a command interpreter. Once we have that out of the way, we are ready to move on to all the other parts, which include getting our characters, our scenes, our music, and everything else working. But we want to get this taken care of first. That way we don't have to come back to it later, and it easily just leads us into the next parts. So before we do that, there's a couple things that we want to fix first. And the first one deals with getting our characters speaking on screen, as far as their names and their text go. In the files we have right now, the way the system works is we specify the speaker followed by their dialogue, and if there's no speaker, then, well, it hides the speaker name field. So we've already got it where if narrator shows up, that it hides it because we want narrator to not be visible. But also, if we don't specify a speaker name here, then it's also going to essentially act just like narrator because it's not seeing anything there, and it's going to hide it. So what that means is if we have a character speaking, we have to specify their name on every single line, and if we don't, then their name won't show up. Just like this, we have John speaking, we have John line 1, but we didn't specify his name for the next line, so when it gets to that next line, it just removes his name. We don't want that. What I'd like is to be able to remove any recurring instances of their name and have the dialogue system smart enough to know that the last person who was speaking must be the one who is still speaking now. And that's very simple to set up. And after doing so, it'll make writing our files just that much more easier. And this is coming from our conversation manager under the line run dialogue coroutine here, where it finds the speaker, and if that line has a speaker associated to it, it shows the name, but if it does not, such as John's second line earlier, then it's going to hide the name. So we can actually remove that because the way we're going to use this system is, the way I want to set it up is if I specify a speaker, like I said earlier, and I don't specify anyone on the next line, I just want it to continue off with the last speaker as though they are continuing. And so by changing that to where we only update the name when it changes, then we have ourselves continuing off with the last name even when we don't specify one. So that's good. That'll make it a little easier writing our files. The next thing I want to do is small but important. If you notice where we set our dialogue instance, it is public and static, which means anything can access it, but also anything can assign it, so anything could change it if we wanted to. I didn't think about it last episode, but a good practice anytime you do this is to make sure that it's publicly retrievable but only privately assignable, just like we did for our text architect. Which means we're going to do this just like we did our text architect. We'll make ourselves have a public get and a private set. So now the only thing that can change the dialogue system is the dialogue system itself. So that brings us into what we're going to be doing today. Now with all that out of the way, we can get started, and the first thing that we're going to be working on is dialogue segmentation. And what a dialogue segment is, it's going to be one part of different parts that make up an entire dialogue line. So we can essentially split up one line in a dialogue file, all the dialogue in it, we can split it up with little symbols that tell the dialogue system to divide each part up and display them independently of each other. So let's take a look at how that will work. With our current system, we have to specify a speaker name and then the dialogue, and for every subsequent line they have to be on a new physical, or I guess logical line, inside of the dialogue file. But with dialogue segments, we can actually combine these into one. So we could have line 2 here, and we could have line 3 up here. And you'd think, well, maybe there's already a new line character. It's just \n. That defines a new line, right? Sure, but this still constitutes one string. What we want to do is split it up into different strings. We want to change the way they render and when they trigger. And so we'll define each segment within the dialog, the same quotation marks, by some sort of symbol within squiggly brackets. So when we have squiggly brackets, it's essentially like splitting the string. We find those, and then we find the different parts of the line. But what goes in here defines the logic of how these segments will run on screen and when they'll come in. And for my experience, as I've been working with this, and I believe there are only 4 different kinds of triggers that you can have. I could be wrong, and if I am, let me know in the comments, and we may adjust that. But there are 4 main types of identifiers that can segment and split up your dialogue into different parts. And that is something to clear the current text on screen and display a new line. There's the one to append text to what's already there. This is stuff that would happen anytime we click. So if we encounter a new segment, it's going to wait until we click and then show the next one. So that would either wait and then clear the previous line, show the new one, or wait for the user input and then just add what we've got on. But there's also one that can ignore user input and just wait for a certain amount of time. And so that would be specified as some sort of waiting period, followed by whether we want to clear or whether we want to append the text after that time duration has passed. And to keep things quite simple, I made these shorthand, which would be C for clear, A for append, WC for wait and clear, and then WA for wait and append. But also, if we're waiting and we're not waiting for user input but time, we need to define time. So we would have a certain number in with this trigger, and these would be our segment identifiers. So then for this line up here, if we wanted to clear dialog line 1 and show dialog line 2, we would just put C in squiggly brackets, and now we've got 2 new segments. If we wanted to append, we'd just do A. You see how that works, pretty simple. As I said earlier, we made a folder in here called data containers, and inside of there, all we've got is our dialog line, which is the base data container for our dialog. And inside, we've got those 3 strings, speaker, dialog, and commands. Well, now comes the part where we convert these strings into their own data types. And for dialog segments, this is what we're going to do. We're going to make ourselves a new class called dialog data. So let's make a new C# script. And since this is part of the dialog line, I'm just going to precede this with DL underscore for dialog line, followed by dialog data. And once that's finished compiling, let's open that up. Okay, so the very first thing we can do is remove start and update, as well as mono behavior, since we won't have any of that. And for us to change our string into a new dialog data, the best thing for us to do is just make another constructor like we did for the dialog line. So public DL dialog data, and we'll want to build this from a string, which would be that whole dialog string that the parsing system extracted from the dialog line earlier. And we'll just call this the raw dialog. And again, for reference, that dialog we're referring to is what's ripped from the line when we get our speaker, our dialog, and our commands. So we've got this new constructor. Let's go ahead and change that in our dialog line. So this.dialog, we'll need to change the type here to DL dialog data. So now we have a data container, and this.dialog will simply equal new DL dialog data followed by the dialog that we ripped from line. And we'll just return false right now, just so that way we don't get compiler errors. We'll come back and fix this in a minute. But with that, we can go ahead and evaluate this line and look for any of those segment identifiers and split up our line into the different segments, which means, as you can imagine, we're going to want to keep track of all those segments, and we can do that with a list or an array, but we're going to need to define what that is, because what we're splitting this into, each segment is going to have some dialogue that goes with it. It's also going to have some kind of signal, which would be the C or the A, whatever that identifier is that says how this line is supposed to start. And if it's waiting, we'll also want to store a signal delay. So we want to store several variables for this, which means we could make a class or we could make a struct. And a struct would be nicer, much more compact for this use case. So let's do that. Let's make a struct for our dialog segment by saying public struct, and we'll call this a dialog segment. And inside of here, we can define the value types that we want a segment to contain. One of which would, of course, be the string for the dialog, and we want some kind of identifier. How do we know which one is which? Well, we can make ourselves an enumeration for reference, and we're going to call this a start signal, because this defines how this segment is supposed to start. So we either have that C for clear, we have A for append, we have WA for wait and append, and WC for wait and clear. But if we have no signal here, such as if it's the first part, the first segment of dialogue, or the only part of the dialogue, then there won't be any signal, so we can also add none in there. And then, to keep track of what the signal is for this segment, we'll say public start signal. Start signal. There, so we have our start signal. And then, if we were waiting, then we also want to keep track of the wait time, so signal delay will represent that float. And that's all the data that we need. So we can populate this dialog data and give it a list of dialog segments, and we'll just call that the segments of the line. So when we build this, in order to get these segments, we're going to need to evaluate that line. We're going to need to rip the segments from this raw dialog. And we'll make this a private function that goes ahead and returns our segments. So public list, give it a return type of dialog segment, and we'll call this rip segments. And what this is going to take is a string for our raw dialog. Okay, and when we construct this data type, we'll say that segments equals rip segments with the raw dialog that we have. Just extract everything from it and populate our list. Alright, so here's where the magic happens. We now have this line, and we need to look for those identifiers. So as you can imagine, like we did for our parser, we're going to use regex for this, just because it's so convenient. But that also means that we need to define a pattern for what it is that we're looking for. So up at the top, when we define our segments, let's also make ourselves a private constant string called the segment identifier pattern. And this is going to be equal to some sort of regex string. First thing we'll go ahead and do is we'll precede our string with an @ symbol, which basically means that anything inside of here is a literal string. Okay, so our backslashes aren't going to mean anything. They'll only be there for the sake of regex when we actually pass it in. But if we were just to leave it in here, we could have a regular old backslash, and that would just be our literal character. But it'll just help in the creation process a little bit. Alright, so there are two different patterns that we'll be looking for. We'll either be looking for a single letter, which would be C or A for clear and append, inside of squiggly brackets, or we'll be looking for the wait variant of that, which would be wait followed by clear or append, followed by the time that we want to wait for the segment to trigger. Let's start simple and just look for the C or A segment identifier. So we'll precede our squiggly bracket with a backslash to escape it, and again that matters for regex, and to make our choice between two options, inside of brackets, we'll say C and A, because we want to look for those two. And then we'll close our squiggly bracket. There we go. And so that is how we're going to identify whether we have C or A. But we also have another pattern that we're looking for. So to give ourselves another option, make ourselves the straight line, the pipe character. And once again, we need more squiggly brackets. We'll go ahead and make the enclosing ones there. And inside of here, we know that we are definitely looking for a W. Okay, we are definitely looking for a W as long as we're waiting. And what comes after the W can either be C or A. Then after this, we're going to have a space, and the space will separate our number from this identifier. And the space is \s, And to represent a digit, which would be the number, would be \d. But as this is, that's only one number, which means it has to be a whole number and you can't have any decimals. You might not want to wait for a whole second. You might only want to wait for 1/10 of a second. So let's make it optional where we can define a decimal point. But in order for this to be any number of any length, let's go ahead and add the wildcard. And so for the period, we need to escape that as well. It gets confusing after a while. I got to keep myself straight here. And if we want to include that, or if we don't want to, because maybe we're using a decimal, maybe we're using a whole number. As long as we can say it doesn't matter if this is here or not, we'll precede it with a question mark. That way it doesn't have to be there. But if it is, then there should be another number on the end of that decimal point. So another digit and another wildcard. And now we can have any fraction followed by this waiting and clearing or waiting and appending command. And that is our identifier pattern, which means we can now, in rip segments, find it. And instead of finding one match, what we're going to find is called a match collection, which is just a collection of matches that regex finds within the line that we feed it. And we can say match collection, then matches, I cannot type, equals regex.matches. What are we trying to match? We're trying to find something within our raw dialog of the pattern of the segment identifier pattern. This right here will find the index of every match within our string. Okay, so we know that it is possible that we can have multiple segments to a line. We also know that we may not have any segments, and we would just have some dialogue in a line. Either way, these are still the same. It just will either find the pattern or it won't. And no matter whether if it does or not, we're still going to have a beginning part that has no identifier, which is why we made that none identifier earlier. So we're always going to have one part, the very first segment, which is going to have no identifier and no delay, and it needs to execute automatically. And the way this is going to work is pretty similar to how we actually ripped our dialogue in the parsing system. If you remember, what we did was we found the index of the starting quotation mark, and then found the index of the ending one, and we also found the index of our commands. Well, we're going to work the same way by finding the indices of these matches, and then basically ripping the substring from this raw dialogue to get ourselves each individual segment split by those dialogue segment identifiers. So we need to keep track of whatever index it was that was on our last match. If we're just starting out, then our last index is obviously going to be 0. And so, like I said, there's always going to be one or more segments, but we're always going to have the first one that doesn't have any sort of trigger. So we can go ahead and create ourselves a brand new dialogue segment, and we need to populate it with that very first segment of dialogue. So if we say segment.dialog, we can assign it a value. And this value will be different depending on if we have a match or if we don't. So let's evaluate that. If matches.count equals 0, that means that we have no matches, and we will simply return the raw dialogue as what will be assigned as the dialogue. But if we do, then we need to find the raw dialogue.substring and start at 0, and then proceed as far as the first match at the index of that match. This will rip the very first segment, or the only segment. And we know we have no start signal, so segment.startSignal equals, and we'll give it none, and then segment.startDelay, I'll just assign to 0 as well. Oops, that was not start delay, that was signal delay. And then we want to add this as the first element in our segments. So we'll say segments.add segment. But we're returning a value, right? So let's define list segment as segments. Let's say it equals new list dialog segment. And though this shares the same name as our list up here, the system knows that we're assigning to this one. You can see that it's highlighted because that was the one defined inside of this field. Therefore, it's not going to reference the one attached to the actual data structure up here. If we wanted to reference that one, then all we'd have to do is precede it by this. Now, the next thing is important. If we don't have matches, we don't need to proceed any further than this. So, if matches dot count equals 0, then we'll just go ahead and return segments. Otherwise, we need to update our last index. So we can say else last index equals matches 0 dot index. And now we continue on and loop through the rest of the segments. So we'll do this with a basic for loop. And then get the match that we're working on. For each match, we'll go ahead and create a new segment. And we want to find whatever that segment identifier was. Conveniently, Regex has already found this for us, but it's going to be in string format. And our signal is going to be in the enumeration format. So first off, let's just say that string signal match equals match dot value. But that's going to grab us not only the identifier, but also the brackets. And we don't want the container, we just want the value itself. So we'll need to separate the value from those containers. So we can go ahead and shorten up our signal match and say that it equals signal match dot substring. And we're going to start at 1, which takes us past the first point, and go as far as our match dot length and subtract 2, because we want to subtract the length of both of these ending brackets and just get the content inside. Now let's go ahead and make sure that what we have is not a combination of the identifier and the delay, such as we would have for WA2 or WC 0.1. We just want the WA and the WC. And that's easy enough since we know that we're going to include a space after the identifier and the number between those two. So let's make ourselves a string and then match data or signal. Let's keep it consistent here. Signal split equals signal match dot split by that space character. Okay, and now we can go ahead and get our start signal. So we'll say that segment dot start signal equals, but we're going to need to cast this as a certain type, which would be our start signal. And that is part of the segment itself, so we'll say dialog segment.start signal as the type we want to cast it to. And following that, we want to reference enum, and it's going to be capitalized, dot parse, and look at that, it's already got the data. So there we go. Parse it as a type of, once again, specifying the segment and the start signal, and only the first match, the first object of whatever was split. If we have a number, then it'll get WA, and if not, well, it'll just get the identifier either way. Also, if enum is not showing up for you, make sure you're using the system namespace. Once again, I'll reiterate that as I'm working, Visual Studio likes to automatically add the namespaces for me, so sometimes I might forget to say what it is. But right now, and it also likes to add ones that I'm not using, which I'm not even using Unity Engine in here. These are the only 3 that we're using. These are the only 3 namespaces that you need to make sure you have included in here. So I need to both look back and make sure that I'm not missing that detail for you guys, and also make sure it's not giving me a bunch of namespaces I don't need, because it does like to do that sometimes. But there we go, that's our start signal. So we'll go ahead and make a note, get the start signal for the segment. Okay, and then under here, maybe we'll have a signal delay. And we know if we have a signal delay if our signal split has more than one value. If it's greater than 1, then we'll say float.tryParse. We want to try to parse the signal split, only the second item. and we want to try to cast it out to our segment dot signal delay. So if we have one, then it's going to go ahead and make sure that we've got both our start signal and any delay that's supposed to be present there. Which means all that we need next is the dialog for this segment. So we know where this dialog starts. It starts at the last index, which was updated to the starting index of the first match. Now, also note that that starts at the beginning squiggly mark. It doesn't start afterwards, it starts at the beginning of the match, and that's what it found. So we'll need to make sure that we exclude that from our search. But also, we need to know the ending point. Where does this dialog segment end? And that would be, of course, either the end of the line or the next segment. So let's get the index for wherever that is. We'll say int next index. This will define how far we go. So we want to start at I plus 1. We want to check if we are at the end of our matches or not. This will determine if we head to the end of the line or not. Since I is our current index, if we just increment that by 1, then we'll know if it's out of range, then we're already on the last match. So if it's less than matches.count, then we want to get this value. We want to get it to the index of our next match. So we would say matches, then I plus 1 dot index. Otherwise, we'll get it at the raw dialog dot length at the very end of the line. And with that, we know where both our dialog segment starts and where it ends. And now we can extract the dialog from inside of it. So let's say segment.dialog is equal to raw dialog.substring. And we want to start at the last index, but remember, it has those brackets. So we want to add to that our match.length. So that way we get right past it. And we want to proceed as far as the next index minus our last index plus match.length. And then we simply update our last index to equal the next index. And when we're done, segments.add segment. And that's the logic to rip all of our lines. But let's go ahead and make sure that we return the segments at the very end of that. And now we're grabbing all the content that we need for our dialog lines. Which means, let's go ahead and test. Where we left off in our dialog system, well, not the dialog system, but the dialog line, rather, we went ahead and said that has dialog is always going to be false, but we know that's not going to be true. So let's come back here, because this is the data type we're now going to reference, and we'll say public bool has dialog, and this is going to be equal to segments.count is greater than 0. As long as we've got segments, we've got dialog. And so let's go ahead and replace this, then dialog.has dialog. So inside of our test dialog files, we can go ahead and see if this is working or not. We grab each line from this text asset. I went ahead and changed the string to a text asset. That way I can just drag and drop ones if I want to switch them out. So we read all the lines from this text asset, and then we're passing it to our dialog system to say all of those lines. But before we do that, let's just make sure that it's grabbing all the data correctly. So for each string line in lines, we want to do something. We'll say debug.log, and inside of here we'll simply say segmenting line and pass in the line that we are splitting up, and say dialog line dl line equals dialog parser dot parse our line. Once we've got that, we've got all the dialog segments, and we can say for each, come on now, for each dialog data dot segment in dl_line.dialog.segments. For each one of these segments, let's go ahead and print out some data about it. So for each segment that I have, I'm going to print the segment number, I'm going to show what dialog is assigned to it, and then I'm going to show what signal is assigned to it, and then if it has delay, I'm going to show that delay as well. And that should show us everything that we need to see in order to verify that this is working correctly. But when we go into Unity, we do get an error here, and that's because we've changed our data type, but we haven't reflected that in our conversation manager. So just for now, let's comment out that line and just check if everything works. So in Unity, in my test dialog files, the file that I'm reading is called dialog segmentation, which if we open up is this one right here. So let's go ahead and make a couple lines and make sure that it's ripping everything correctly. So let's say that this is my dialog file. So we could run everything just like this and have it as one line, or maybe we could split these up into different parts. So Detective says this changes everything and we're dealing with a whole new level of evil here. If I wanted to split up these two lines, maybe I could add the append symbol, and that would go ahead and append that. Then maybe we'll go ahead and set the clear symbol here, that way we split that up into two separate lines. Maybe in that same line, we'll have him pause here, and then maybe wait and append after 1 second, and we'll go ahead and clear again here to make a new line. We'll wait and append for another second there, and right here, we'll go ahead and wait and clear after 0.5 seconds. So now this splits up all of our lines into multiple lines without having to separate them into their own specific lines within the file itself. Once again, I've got all these blank lines, so I'll first make sure the line is not blank. Okay, so we see that it splits and we get the speaker as a detective and this whole thing is our dialogue, but then when it tries to find the different segments, it's saying that requested value A was not found. Perhaps because we're looking for the signal and we're trying to match it to an uppercase when I defined lowercase. So what I could do instead is when I'm trying to find it, I'll simply say .toUpper and convert it to uppercase no matter what it is. And there we go, we have a nice list of 39 items, which means it worked, we don't have errors, so let's take a look at this first line. We only have one or two segments here, split up by the appending signal. So we find speaker, we find the dialogue, and then segment 0 is identified as this changes everything, which comes before the appending signal. The signal is none. And then segment 1, the second one, is everything that comes after that, including that little space, so it is appending. And this signal equals A, which means append. Great. Now we have C and WA in this line, and of course segment 0 is I know, which comes before them both. And then it's hard to believe someone could do something, ... which comes after clear, indeed has signal clear. And then we wait for 1 second to show like this. Third segment is indeed like this after waiting for 1 second. So that's perfect. Every single one of our segments is ripping as it should. So since we know that's working, we can go ahead and remove all of that and go ahead and send it back to our dialog system to go ahead and say all of these lines. If we look at that, we're going to send everything to our conversation manager. So what is this going to do? Start our conversation. And inside of here, of course, we go down to run dialogue, we find the speaker, and we commented out the actual part to build the dialogue. So let's go ahead and uncomment that again. And you'll notice we have line.dialog being underlined here in red, so it has an error because of that type. So build dialog is currently set to take a string when we're trying to pass in the data type with multiple lines. This line that we're trying to pass in has multiple parts to it, and we need to render each one separately from each other. So we need to make a new method that's going to take this data type instead of the regular old string format. So once more, let's make ourselves another IEnumerator, and we'll call this build line segments. Okay, so build line segments is going to handle the line, and then in here we'll be calling this build dialog function. So we'll just go ahead and return build segments. Where is it? Build line segments. Forget what I call it, just like that, and it's right there in front of my face. And what we're going to pass in is our DL dialog data and call this the line. Okay, so there we go. Now we fixed that. So what are we going to do in here? Loop through every single one of our segments and then show the dialog on screen. So let's start with a basic for loop. For int I equals 0, while I is less than our line.segments.count, then increment I by 1. And let's go ahead and grab our segment. So DL dialog data.segment segment equals line.segments I at the index we're working with. Okay, great. Now, before we actually trigger this, we need to wait for that user input. So if we have C or A, then we know we're going to be waiting for user input to either click the keyboard or click that button on screen to display it. If we're waiting, we need to yield for whatever time duration, and maybe you'll have more segments than this. Maybe there's more that I haven't thought of. So let's make ourselves a separate function that's going to handle all of these independently. And this will be a fairly small one as well, which is why we'll go ahead and add it right below here, IEnumerator, and we'll call this wait for dialog segment signal to be triggered. And what we're going to do is also take in our segment. We're going to take our segment right here, so we'll just copy that and paste that as the parameter. And we will yield return wait for dialog segment to be triggered. Wait for this to happen. All we're going to do is we're going to call a switch in here. And we're going to pass in the segment.startSignal to evaluate how we need to wait. So our first case is going to be the signal C. Now, C and A are going to have the same requirement. You just need to click on screen. So we can put them in the same case just by layering them on top of each other, just like that. And then our next one that we'll be looking for is A. Well, not A, it's a WA for wait and append. And just because I have C on top up there, I'll make the top one here also WC. There we go. And if we hit some other thing, which would really be none here, all we're going to do is break and not do anything. So if we come in here, if we have C and A, we're waiting for user input, which means all we need to do is yield return wait for user input, because we've already defined that down here as waiting for that button prompt or the keyboard to be clicked. So we just wait for that. Whereas if we have a waiting command, then we're going to yield return new wait for seconds, and we're going to wait for the segment dot signal delay. So after we've waited for that time, waited for that trigger, then the next thing we want to do is wait for the dialog to build. So we can say yield return build dialog and pass in the segment dot dialog. And that'll go ahead and render it on screen. But if we look at build dialog, the only thing that's happening is the architect is building it, which means it's starting a new line. So we want to make sure that we can also append. So in addition to this dialog here, let's also make ourselves a boolean called append. And by default, just set that to false. And so if we are not appending, then our architect should build the text. Otherwise, our architect should append the dialog. Just like that. There, and add yourself some comments if your code starts to get too big so you know what section does what. Just good practice there. Okay, so we've got our signals, we've got waiting for dialog, but now we need to tell it whether to append or not. And we can do that by checking whatever our signal is. But we've got multiples that could possibly equate to appending. We've got A and we've got WA. And this would kind of turn into a long line if we try to check for those, because we'd have to say DL dialog data dot segment dot start signal, but wait, that's not true. We also have to do segment dot start signal equals start signal dot A. If it equals A, we're going to append, but if we've also got WA, we need to say, or our segment dot start signal equals dl dialog data dot segment dot start signal dot wa. And you can see how this will get very long. So it'd be nice if we just go ahead and put that into a variable we can access straight from within the segment. So let's get rid of that, and let's hop into our dialog segment here and make ourselves a boolean, public boolean, and call this append text, and set that equal to a certain value here. So that's going to be, we will append if our start signal equals start signal.a, or our start signal equals start signal WA. That's when we're going to append. Let's come back to Conversation Manager and set append to segment.append text. Just like that, we've gone ahead and added additional segments into each line of our dialog. So now all that we need to do is run that through Unity. As we enter in Unity here, no errors, nice. And we can see over here on the side exactly what we're going to be building per line. So we see the very first line we should have this changes everything show up, and then we need to wait for user input and then append the rest of that line. So let's see if that works. This changes everything. It's only rendering that part. Now it already knows that it's got the rest of this line to deal with, so if we click the screen, there we go, it appends. And now we should move on to the next line to say I know, and clear the screen. It's hard to believe someone could do something, and we waited for that 1 second and then appended the next text. And then we need to find this killer, put a stop to experience, and clear it. There we go, it's waiting for me. I click, and now it cleared and finished the rest. Awesome. So we can see that this system is working pretty well. We've got this split up into 3 different segments here. So the first part's going to wait for 1 second. There it goes. And now it's waiting for me to append. It appends, and now it should wait and append. There we go. Yes, everything looks like it's working fantastically here. So I believe that is it for our dialogue. This actually gives us a really nice way to write multiple lines into one quotation mark for the characters. And as we do more and you write more and more in your dialogue files, this will make a big difference, trust me. And in the next video, we're going to pick up from this and go ahead and make our speaker data, get all the casting information from it, and that's going to be pretty useful in the future as well. So hope you enjoyed the video. I will see you in the next one.